This work addresses the challenge of handling robot component communication in reality and also in simulation. We propose a network topology extension integrated into robot model files that reflects the connections between components in a standard way. Although this will not affect the visuals of the simulation model yet, it still provides a common platform to handle components as a complete system using standardized technologies. The components are developed in the robot operating system environment where the devices are organized in separate packages inside a workspace. Typically, these contain the model file and a description about the physical look and also our interface extension. Having a description about well-known robot interfaces is the basis of our contribution. Integrating device interfaces using standard IETF young data models provide a strong contribution towards a connected robotic ecosystem. Generally, these description files contain the 3D model of a device. With our extension, these are able to represent the communication interfaces with the relevant properties. This layered extension aligns with the RFC 8944, which is intended to define a young data model for Layer 2 network topology. After modifying this model with attributes for this field of application, it can handle connections between defined nodes, link them and show the connection properties of the complete robot system. All young definitions are specified within a module bound to a globally unique identifier, an XML namespace. To include IETF standard or custom modules, XML namespacing is used consequently. Thanks to the modular architecture, the components can be grouped into a higher hierarchical system file. And now, let's see in practice. After building and starting the system, we get the following result. Here you can see a networked robotic system example with the components tagged. All these devices are extended with their interfaces according to their datasheet. For example, the control box of the robot arm has an USB 3.0 and USB 2.0 and a gigabit Ethernet port. These interfaces are added to the control box model. First, the links to connect to the control box and then the explained interface properties. We created a dedicated tool to provide a graphical user interface for editing the presented robot description file. It handles the model descriptions by separating into topology levels. Editing on the GUI prevents creating false data and linking. The tool helps managing different configurations of a network and compare them to decide which one fits better to the requirements. It is also capable to export only the network information in a young-conform way to be able to validate the data against the young modules. A complete robotic system realized with the tool looks like in the picture. The networking layers are stacked vertically, with the edges between the devices reference the supporting connections between them. During the edge creation, the user only needs to make them manually in the topmost layer. The tool adds the edges in the lower layers automatically. A control loop can be easily defined with this selection dialog. Based on the given nodes, the tool will find the shortest path between them and take into account all the other devices that take part in the communication and the interfaces they use. After that, using the stored information, it calculates the scores for the defined metrics. Using this tool, it not only capable of extending robot components with interfaces, but with our custom tool it is able to represent the topology, and based on that, it calculates various scoring that characterizes the system.